So this actually shouldn't be new. We've done balanced chemical equations before. In fact, we had that whole chapter on them. What was that, like 2 or 3 chapters ago? So most of this shouldn't be new to you guys. Maybe a little bit of a refresher, but mostly not new. All right, we're going to start with lead 2 nitrate. Nitrate is NO3. So it just says lead 2. That means it's lead with a +2 charge. Nitrate, there's nitrate. He has a -1 charge. So that means I need to put parentheses around him, and I need 2 nitrates to cancel out the +2 of the lead. 2 of my -1s to cancel out the +2 of the lead. So that's lead nitrate. And I'm going to add that. Today we're going to look at adding that to potassium iodide. Ki, potassium iodide. K +1. Iodine, -1. That's a 1-to-1 ratio. That's pretty easy. Don't need to worry about any subscripts, just 1K, 1I. Mohammed, you with us? Double replacement actions. We've got a positive, we've got a negative. We've got a positive, we've got a negative. Again, the idea here is that the 2 positives are going to switch. Going with different partners. Quite frankly, it doesn't matter which one you write first. Completely up to you which one you write first. Completely up to you. I'm just going to go with PB since we have that one here. So PB, he's not going to be with NO3 anymore. He's now going to be paired with I. All right, we said over here, lead has a +2 charge. Iodine has that -1 charge. So I need 2 iodines to cancel out my 1 +2 lead. Cool. All right, so there's lead iodide. And now we have potassium, that's our other positive. And he's going to be paired with our other negative, which is nitrate. Potassium has a +1 charge. Nitrate has a -1 charge, so this works out again. That's a 1-to-1 ratio. No need to write in any subscripts. We're good. We're good. So, hey, guys, once you're good at that point, once you've got your subscripts done, don't worry about subscripts again. We're going to need to balance this, but you can't balance it with subscripts moving forward. You're going to have to use coefficients. Those are the big numbers. All right, so let's balance. 1 lead, 1 lead. So good start, 1 and 1. Nitrates, I've got 2 nitrates. Over here, I've only got 1. How do I fix that? Not a parentheses and a 2. Instead, we'll use coefficient 2 out in front. Cool, now I've got 2 nitrates and 2 nitrates. Unfortunately, that messed up my potassiums. I have 1 and I have 2. Well, that's okay. I can fix that pretty easily. Just put a 2 out in front there. And hey, that actually worked out really well because now I've got 2I and 2I. Sweet. Balanced. How about them apples? You guys want to see it? Watch this reaction happen? Yeah, like I said, this is an exciting unit. This is a good unit. Okay. 2 at home, hang on. That's a good one. Okay, let's do it. What do you guys want to add first? Potassium iodide. All right, here's my potassium iodide. Don't need much. A little drop will do here. It's actually probably way too much I actually need. But make sure you guys can see it. You see that in there? Yeah, that light's kind of. Let me take a look at that light. Careful, I should drop through. All right. See that black cloud over there? Yep, if you turn it, then yeah, there we go. Hey, does that work better? You see the, Yes, oh, that really didn't do anything, did it? Son of a gun. We just can see a little bit of salt in there. Yeah, that's better. There's no glare from that window now. You see the salt? Man, isn't it weird how in chemistry everything's just a white salt? Kind of weird, huh? All right, well, see what happens. Too much. And see, this one's just a white salt also. See on the tip of the scoopula there? He's ready? It's good. I had a kid that sat right there last period. I told him to watch out. He's ready? Huh. Nothing happened. That's kind of boring, wasn't it? Let's shake it up a little bit. Anything happening? There's a bunch of white salt. Nothing happened. Man. Man. Well, what do we forget to do? What did we forget to do? Kind of. Kind of. Hey, here's something you guys all hate doing. Most you hate doing. I don't know if you all hate doing it. A lot of you guys hate doing. You have to do it. You have to do it. States of matter. States of matter matter. You guys see me drill you on points with that, right? And then I write states of matter. Well, you got to do your states of matter. States of matter. States of matter. Yes, exactly. Exactly. All right. Hey, first rule. Lead, nitrate. Anybody find a rule involving lead or nitrate? Yeah, goodness, I hope so. It's rule number 1. It's the first word on there. Hard to go much past that. Nitrates are soluble. So that means this is soluble. That means it will dissolve in water. Yes, aqueous. How about potassium iodide? Anybody see a rule for Ki? Potassium iodide? Awesome. I see some fingers up. Heard some in class here. Absolutely. Rule 3, halides, which includes iodide. They are soluble. There are a couple of exceptions, but K is not one of them. So yes, definitely soluble. Hey, pretty common. A lot of people skip over rule 2. 1A, alkali metals. Guess what? Potassium is a 1A alkali metal. So rule 2 would also work. They're also soluble. So rules 2 or 3 would work. This one is soluble. It will dissolve in water. Yes, 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 yes. All right, how about lead iodide? Lead iodide. What rule can we use for lead iodide? Yep, heard someone say 3. Absolutely. Rule 3, there's our iodide. They are soluble. except silver, lead, and mercury. Guess what? Now we're working with lead. So if it's not soluble, that means it's solid. Again, soluble means it dissolves in water. Not soluble, insoluble, means it'll remain a solid. Finally, potassium nitrate. Well, hard to even start reading the rules without reading the word nitrate. Nitrates are soluble, but also rule 2, group 1A alkali metals, which is potassium, are soluble. So yeah, it's soluble. Definitely. All right, so hey, that kind of explains it. That's what we forgot to add water. Nothing happens without water. Let's try this again. Let's try this again. Uno, dos, tres. Whoa! Something happened. Whoa! White salts turned yellow. By the way, people at home, it's a much brighter yellow here in class than what it is on the camera. The camera's not even doing it justice. Woo! Well, that was funner, wasn't it? That was a lot funner. Yeah. Cool. Hey, that's why states of matter matter. States of matter. Yes, that matters so much. Let's take a look at what actually happened. What are we saying? When we have this balanced chemical equation, what are we actually saying? Well, for lead nitrate, we've got 1 lead, 2 nitrates. That means 1 Pb and 2 nitrates. And they're going to flank them on either side. Because they're negatively charged, they don't really want to be near each other, so they kind of spread out on either side of the net lead. So that's what lead nitrate looks like. If you could see it at a small enough level, they can't. We don't have anything powerful enough, any microscope powerful enough to see down to the atomic level. But if you could, here's what you'd be looking at. 2 nitrates flanking a lead. All right, now we added that to 2 potassium iodides. 1, 2. At first, nothing happened. Nothing happened. It's just 1 salt and a second salt. There was no reaction. We could not break the bonds between the Ki or between the Pb and the NO3. And if you can't break the bonds, how do you expect to form new bonds? No chemical reaction. So instead, we had to put them into water. And when we did that, when you put these salts into water, they dissolve. That's what aqueous means. It means they come apart, they dissolve. So I get my lead ion, Pb. Now he's an ion now, he's gonna have that +2 charge. So I got my lead ion, and then floating away from it, no longer attached to it, is a nitrate ion. And guess what? I need 2 of those nitrate ions. Put another one floating around down here. And then I also had a potassium ion, and an iodine ion, and another potassium ion, another iodine ion. And when I added water, they all kind of broke up and just started floating around. That's what dissolved means. That's what aqueous means. When you put table salt, which is sodium chloride, NaCl, into water, the reason why you don't see it anymore is because this is what happens. They dissolve, they break, they are those white crystals, but they break apart into all these different components. That's what dissolved is. That's why you don't see them in the water anymore. Too small to see now. We don't see a white crystal. All right, so now that all of the bonds are broken, now we can form new bonds and our chemical reaction can occur. First of all, looking back up at a balanced chemical equation, what is still an ion? What is still dissolved in here? You've got two options. Which one of these two is still going to be just dissolved and floating around?
KNO3.
Nice. Thanks, Caitlin. Yeah. KNO3 is still aqueous. So go ahead and put my K. Again, he's got a plus charge. Got to draw a second K. So we got two of them. I got an NO3. He's still going to be floating around out there. NO3. Floating around out there. So those guys are still kind of floating around the water. What's going to turn solid and precipitate out, fall to the bottom? Yep. This is our precipitate. This is our solid product. So I'm going to go ahead and draw it down here at the bottom, PB. Now, look, there's no charge on him anymore. The reason why it's not a charge is because his positive charge has now matched up with two negative charges, and the charges cancel out. Now I've got them down at the bottom. They're going to form up. They're going to form a solid. They're going to sink to the bottom. We're starting to see it a little bit. You know how, like, the reason why the whole thing is yellow? The reason why the whole thing is yellow is because, you know, you mix like dirt with water and it's like really murky and brown for a while, and then you just got to let it settle out. And after it settles out for a while, you get all the sediment slowly filters out, and then you get some clear water on top. By the end of the period, you guys, at least here in class, will start to see you guys can see the solid on the bottom, though. See the solid starting to form on the bottom. By the end of the period, we should start to notice some, you know, should be a little clearer up here at the top. It's just still settling out. It's just still settling out. That's all we have happening here. Cool. Questions? Awesome. Okay. So here's kind of the new stuff. Again, this isn't new, guys. We did a whole chapter on this type of stuff. What's new is now we need a better way to describe what's actually going on. You guys just saw it. When I mixed these two salts, nothing happened. So our new stuff, this is the CIE. The new stuff is a lot more specific to what actually happens here. So the CIE stands for the complete ionic equation. For the complete ionic equation, we have to, again, we're just doing a better job of describing what is actually happening. All right. Well, really, what we really have is one ion of lead. So you've got an ion there. He's not like he was up here. He's not bonded to anybody. Really, he's just kind of floating around in the water. I have 2 ions of NO3. Now up here, I've got the 2 behind it because they're stuck together. But really, they aren't stuck together. We put them in water, they aren't stuck together. They're all floating around. So a better way to describe 2 NO3s is with a big 2 out in front. Now don't forget the charge. Put a negative side. It's an ion now. It's kind of floating around in water all by itself. If you like to put a negative and then a 1 after it, that's absolutely fine. You know, like I got positive 2 right there. You put negative 1 if you wanted to. Or you put 1 negative. You like to put the number first, then the sign. That works also. I usually just put the charge, because it's just 1 negative. That means just 1 negative. But however you are comfortable writing, you can go for it. Nitrate has a negative 1 charge. Let's see, we've also got 2 potassium ions in there. And we've also got 2 iodide ions in there. This is a much better representation of what we actually have going on. Much better representation of what's up here. If you're writing a chemical reaction, remember, you didn't see anything happen when we just mixed these 2 salts. You watched it, you saw. Just 2 white salts that sat there together. So this really isn't telling us a whole lot about the reaction. This, though, hey, we got all these ions floating around in water. That tells us a lot more. Now I'm out of room up here, so I'm going to come down here to finish it. Lead iodide. Hey, not ions anymore. These guys are back together. PBI2, and they're a solid. That's what I actually formed here. My solid lead iodide. On the other hand, I still have 2 potassiums and their ions. And I still have 2 nitrates and their ions. So notice my potassiums and my nitrates didn't actually do anything, right? They're ions on this side, they're ions on this side. They didn't really change. They actually weren't really even part of this reaction at all. We have a special name for them. They're called spectator ions. You know, people that go to watch a basketball game, they're spectators. They're not participating. They're not a part of. They're just watching. They're spectators. So these guys are what we call spectator ions. We'll take a little note over that in just a second, but first, let's finish up really describing what's going on here. So this is the CIE. We also have to take a look at the NIE. Net ionic equation. You guys have heard the term net before? You probably hear it in math class, or if you're in a business class, when you're in business class. But like, let's say I go out and I spend $100 on hot dogs. Then I turn around and sell those hot dogs for a profit of $200. What's my actual net profit? I spent $100 to buy the hot dogs. I sold them for $200. Now my net gain is 100. I had to spend 100 to make 200, so my net is 100. Kind of the same thing. The net ionic equation is what is actually happening. And in order to best show that, we have to get rid of the spectator ions. They didn't do anything. They weren't really part of the equation. What actually happened? What do we really see happen? Well, what we really saw happen was lead ion reacted with iodide ion, two of them, to form PbI2 as a solid. That's what I actually had happen. You sometimes see this question. I don't think I asked it on the homework this year, but it goes with this material, driving force. I'll come to see it as the DF. And the way that you answer this, the driving force, is formation of a solid. It doesn't necessarily have to be a solid. We'll do some more of these later next week, where our driving force is a liquid. We form a liquid. You could potentially form a gas, in which case you'd say formation of a gas. But whatever your non-aqueous particle is, or solid, liquid, gas, whatever it's not aqueous, that's what your driving force is. So that's how you answer that question. All right, as promised, a quick little note here on spectator ions. So ions that do not participate in the reaction are called spectator ions. We just kind of mentioned that. They just go to watch. We do not include them in the NIE, net ionic equation. Okay, a question? I feel like your hand is up. One of those bits. You and Della are never here on the same day anymore. You want to tell her?
Della, I'm ready. Not coming to school.
She laughed. Questions? I have one more example to show you guys. I'll keep it quicker. Don't have to do all the notes and all the talking and everything. So I'll keep it quicker. Just one more example to show. But I'm going to turn the page to do it. So any questions on our first page here? Everybody's good so far? Cool, cool, cool. All right. All right, so the balanced chemical equation. This time we're going to do chromium 3 nitrate. So chromium 3 means it has a positive 3 charge. We just talked about it on the last one. Nitrate has a negative 1 charge. So it's going to take 3 of my negative 1s to cancel out the positive 3 of chrome. Okay? This time we're going to react that with iron sulfate, iron 2 sulfate. So iron 2, that means it has a positive 2 charge. Sulfate, also a 2 charge, a negative 2. That's nice. That means they cancel out. Positive 2, negative 2. It's a 1-to-1 ratio. They cancel out. So I don't need to put any parentheses. I don't need to put any subscripts. They're good. Again, working with a double replacement. That means our 2 positive ends are just going to switch places here. Doesn't matter which one you write first. Chrome is now going to be paired with sulfate. Now this gets a little ugly. Chrome has a +3, at least the one we're working with does. Sulfate has a -2. It's hard to balance a -2 and a +3. My suggestion is to cross over. So this one's -2. So bring the 2 down here. We need 2 chromiums. This is +3. So we're going to bring the 3 down here. 3 sulfates. And good way to check your work then. If this is -2, 3 times -2 is -6. If this is +3, 2 times +3 is +6. All right. Cool, we did it. They cancel out. 0 overall charge. Fantastic. All right, I think I'm gonna run out of room. If you guys have room, go for it. But I'm gonna come down here and write plus. Let's see, plus we have iron now paired with nitrate. Our iron had a 2+ charge, so that means we're going to need 2 nitrates. All right, so we're balanced for charge. That means we have the appropriate subscripts. Don't mess with subscripts ever again. Now that we balance it, and yeah, we're going to take our time and balance it, but now that we're balanced, do it with coefficients out front. Don't go back to the subscripts. Don't change those. All right, let's start with chrome. I've got 2. I've got 1 here, 2 there. Well, that's a pretty easy fix. Cool. 2 chromes, 2 chromes. Good start. 3 and 2 of them. Again, if I were to draw this, and I'm going to use symbols this time because I don't want to draw all the ions. So I'm going to use symbols. Chrome, we'll do with a dark dot. Nitrate, do it with an open circle. That's 3 nitrates per dark dot, right? That's where there's 3 of them per chrome. And then I've got 2 of the whole thing. So I've got a total of 6 nitrates. 6 nitrates. Come over here. Here's my nitrate. I've only got 2 of them. So to get 2 up to 6, I need to multiply it by 3. Now I've got my 6 nitrates. Hey, I messed up my number of irons though. Now I've got 3 irons. 1 iron. Well, that's a pretty easy fix. Just put a 3 out in front. Now I've got my 3 irons, and hey, look, that balanced my sulfates also. I have 3 sulfates. I've got 3 sulfates now. Sweet. I'm going to stick with my pattern here. I'm going to use X's for iron and an open square for SO4. I've got 3 of them though. So that's kind of what this reaction looks like. 2 chromium nitrates reacting with 3 iron sulfates. Hey, just like that reaction we just did, guys, nothing is going to happen unless we put them into water. If I mix these salts together, nothing happens. Well, what's going to happen when I put them in the water? Cassie? Great question. No, on your homework, so obviously you guys got some problems like this on your homework, you do not have to make the diagrams. If they help and you want to make them, go for it. But you are not required to make the diagrams for homework. Good question. All right, well, let's start with chromium nitrate. What is going to happen when we put chromium nitrate in the water? It is soluble. Yeah, it should be the easiest rule up there. Look, nitrate, first word on there. Nitrates are soluble. Soluble means it will dissolve. Cool, so we're going to end up with little dots. 6 of these open circles. All right, very good. How about iron sulfate? What's going to happen when we put iron sulfate in the water? What rule tells you that? That's at sulfides. So close, very close. The sulfides, though, and we have a sulfate. Bless you. Rule 4 is our sulfates. SO4 -2. They are soluble. There's a couple of exceptions. Barium, lead, calcium. We don't have barium, lead, or calcium. We have iron, so this is soluble. So aqueous. So that means I'm going to get 3 X's and 3 squares. All right, here's my pool full of ions. Let's see what they're going to form. Well, chromium sulfate. Okay, let's take a look at the rules. What rule did we just say for sulfates? Rule 4, sulfates are soluble. Couple of exceptions, barium, lead, calcium. We have chrome. None of those 3, so soluble. So that means my chromium is going to remain as just black dots. And my sulfates, I use squares for those guys. Those guys are going to remain as just open squares. Nothing happened with them. Okay. How about iron nitrate? Yeah. Hard to read any rule without reading number 1. Nitrate. Soluble. Not even an exception to go for. So this one is aqueous also. So when this guy's in water, again, what I use for iron, I use the X. Got 3 X's. Nitrate, I use the open circle. I've got 6 of those guys, 3 and 2 of them, so 6 open circles. Anything happen? I'd say not. Cool. All right, let's say there's a complete ionic equation. Let's give ourselves a better picture of what we're kind of seeing here. We know nothing's going to happen if we just have these guys out in open air. So instead, what do these ions look like? Well, with 2 Cr ions, we said those are +3 ions. Make sure they're floating around in water. We have 6 nitrate ions, 2 and 3 of them. Three iron ions, there's iron 2, so it's a positive 2 charge. And 3 sulfates. Sulfate has a negative 2 charge. Okay, so this is a better description of what we have on this side, our reactant side of the beaker. We just have a whole bunch of ions floating around in there. Total of 2, 6 is 8, 3 more is 11, 3 more is 14. We got 14 ions floating around in here. On this side, I'm gonna get a look up here. Okay, this one's aqueous. I still got 2 chromiums. Three sulfates. This one's also aqueous. I have 3 irons. Oops, wasn't plus 3, it was plus 2. And 6 nitrates. Again, I ask, did anything happen? Nothing changed. We might have gotten some ions to move around. They might not be in the same places they were on both sides, but nothing actually happened. We didn't form anything. There's no driving force. Everything started off as an ion, and everything finished up as an ion. Nothing changed. So when we go to write the NIE, the net ionic equation, guess what? No reaction occurred. Jack, stay with us, almost done. Nothing happened. One last little note on that. When everything turns out to be a spectator ion, nobody actually reacts, nobody does anything, you write no reaction in R for the net ionic equation. Questions? Cool. Cool. So somebody already asked, or I don't know if they noticed or they just assumed, yes, there absolutely is a homework over this kind of stuff. No, you do not have to diagram anything. You can, you're welcome to. If it helps, awesome, go for it. But there's no requirement for you to diagram anything at all. If you don't want to, you don't have to. You just have to write the BCE, the CIE, and the NIE, if there is one. It might not be. You might have a no reaction for any particular problem. People at home, how is Lemonade Lab? Reminder that that's due tomorrow night. I think I left you guys with one problem you had to do on your own. So far, we got that problem done. If you didn't, and you have any questions over it, right now would be the time to ask. Or you can come into office hours, 2 to 2:30 today, 2 to 2:30 tomorrow. But make sure you guys are doing that because it's due tomorrow night. So if you haven't done it yet, get that done. This homework, 12.1, this homework isn't due until Tuesday night next week. So once you guys finish the Lemonade Lab, if you want to take a nice long weekend and wait until next week to do the homework, that's absolutely fine by me. Those of you guys who'd like to get your homework done, though, you can't wait to get that stuff done out of the way. Go for it. You can get it done. It's open. It's available to you, but not due until next Tuesday. No e-learning Friday this week. How about them apples, huh? Pretty cool stuff. Are you guys disappointed about the lack of e-learning Friday? Oh, what are you guys gonna do? I'm getting so bored. All right, well, any questions over Lemonade stuff? Fantastic. Well, people in the classroom here, I know they're going to finish it because we got half an hour and they're going to finish it. So you guys, I'd make sure you do the same. It's due by tomorrow night. Come back if you have a question. But otherwise, guys, have a great long weekend. I'll see you next Monday.